Morning, algebra students. Hope you're having a good Friday so far. Today we're taking 9.7 day 2 notes. This is continuing on with factoring and solving special types of polynomials. As you go through the steps to factor, these are the things I want you to look at and focus. Can you factor out a negative? Can you take out a GCF? And then for today, it's mostly going to be focusing on 5 and 6, which are, is it a difference of two squares? Is it a binomial square? But we still need to look forward to see if we can take out a negative or possibly even a GCF. On number 1, definitely need to take out a -3 here. The leading coefficient is negative. Both of these factors share a 3, so I take out a -3, and I'm left with m squared minus 16n squared. This is a difference of two squares. It's one perfect square minus another one. The square root of m squared is m. The square root of 16n squared is 4n. So I need an m plus 4n and an m minus 4n in order for the middle terms to cancel out. So this is your complete factored answer. Don't forget the -3 stays out in front. It is important to keep that out. We pulled it out for a GCF. On number 2, I'm looking at the n terms and I'm thinking, wow, 49a squared, that's a perfect square, and 1 is a perfect square. If that's the case, it's more than likely a binomial square. The square root of 49a squared is 7a. The square root of 1 is 1. So in the first term, I need a 7a. In the second term, I need a 1. 7a plus 1 quantity squared would be how that factored. The only thing I want you to do now is real quick check the middle term. 7a times 1 is 7a. Double it to get 14a, which is right there in the problem, 49a squared plus 14a plus 1. So if I were to multiply this quantity by itself, I would get 49a squared plus 14a plus 1, but factored, it's written this way. On number 3, I'm looking at this one, and I'm seeing, oh, a perfect square, another perfect square on both ends. So not only do I have to factor this one, but these say solve as well. So the square root of x squared is x. The square root of 16 is 4. X plus 4 quantity squared set equal to 0. Double check to make sure this is your middle term. X times 4 is 4x. Double it is 8x. Yep, that's what I have for the middle. So now I can solve this x plus 4 quantity squared equal to 0. Now technically there are two of them because it's quantity squared. So really you only need to set one equal to 0. X plus 4 equals 0. Subtract 4 from both sides. X equals -4. Number 4, GCF that puppy first. Take out the 4 and have w squared minus 9. This is two terms. I'm seeing a square on one side minus a square on the other. It's probably a difference of two squares. So I have the 4 out, and then I have a w plus 3 and a w minus 3. Because 3 times 3 would be 9. The two middle terms would cancel each other out. Since I'm solving this one, and this is not a variable on the outside, you can just cross it off and set w plus 3 equal to 0 and w minus 3 equal to 0. So w equals -3 and w equals +3, or you can write it as plus -3. On number 5, you need to bring the -2536 to the other side. And I'm looking at that like, man, I can square root the top and I can square root the bottom. Square root of 25 is 5, square root of 36 is 6, and of course the square root of y squared is y. So this one becomes y minus 5, 6 quantity squared. And then you'd set that equal to 0 and solve it. Again, you're only setting one of these equal to 0 because it's quantity squared. Y minus 5, 6 equals 0. Add 5, 6 to both sides. Y equals 5, 6. On number 6, bring the -16 to the other side. -9c squared plus 16 equals 0. Leading coefficient is negative. Factor out a negative. Then you're left with 9c squared minus 4. You have the negative out in front. This is a difference of two squares, 3c plus 4 and 3c minus 4. Square root of 9c squared is 3c. Oh, Ms. Lee, this should be a 2 right here. So it should be 9c squared minus 4, but then this should be +2 and -2, which is, of course, going to change these. I apologize. You're going to have 3c plus 4 equals 2, and 3c minus 4 equals, or 3c plus 2 equals 0, and 3c minus 4 minus 2 equals 0 as well. So your answer should be positive and negative 2/3 instead of 4/3. Again, this should be a 2 right here, so 3c plus 2 and 3c minus 2. So a -2/3 and a +2/3. Number 7, I'm looking for the value of k that's going to make this a perfect square trinomial. So the square root of 81 is 9. Double it for the middle to get 18. So it should be written as x squared plus 18x plus 81. So you know that k equals 18 there in the middle. The last one is a vertical velocity formula. And there's an example of this on your page that I printed out from the book. There's a page in your book which has more information on it. But let's just remember that t equals time, v equals initial speed, and s equals the starting height. A hickory nut falls from a branch that is 100 feet above the ground. After how many seconds does the hickory nut land on the ground? If it falls, the initial velocity or speed is 0. So v equals 0. If it's going to land on the ground, the height is going to be 0. So I set everything equal to 0 at the end. 0 equals negative 16t squared plus 0t, because that's my initial velocity, plus 100 because it starts from 100 feet off the ground. Remember, we're solving for t. How long is it going to take? So negative 16t squared, that cancels, plus 100. Take out a negative. Take out a negative 4, in fact, and you have 4t squared minus 25 equals 0. This is a difference of two squares, 2t plus 5 and 2t minus 5. Set both of them equal to 0. 2t plus 5 equals 0, and 2t minus 5 equals 0. t equals negative 5 halves, but you know that time cannot be negative, so that one's a goner. And you have 2t equals 5, t equals 5 halves, which is 2.5 seconds. Therefore, it would take 2.5 seconds for that to hit the ground. Your homework is page 603 to 604, 4 through 42 even, 46 and 48. Have a good rest of your day. Email me if you have any questions, and have a good weekend.